Hey everyone, today's lesson is on double replacement reactions. So in the previous video you guys learned about single replacement reactions where you have one element by itself and then it kicks out a bonded metal and forms its own bond. Double replacement is going to be similar, except you're going to have A switching spots with C, and instead of C being left alone, C is now going to bond with B and A is going to bond with D. So it's just a switching of the partners here. So this chart that I'll have attached to your assignment post of the solubility rules, this is going to be important when we're figuring out whether or not a double replacement reaction is happening. So solubility just means, is something able to dissolve in water? So what that looks like, if we have potassium iodide and lead nitrate reacting together in a double replacement reaction. So previously we talked about, the AB plus CD example. So A and C would be K and PB. So potassium will switch places with PB, with lead, and then lead will now bond with iodine, and potassium will now bond with nitrate. But before we get to that, I want to point out one thing right here. So if you look next to potassium iodide and lead nitrate, you see a parentheses AQ. And all that means is that these compounds are aqueous. And if something is aqueous, that just means it's able to dissolve in water, which just means it's soluble. So when you have an aqueous solution of potassium iodide, the potassium and the iodine aren't actually bonded together. They're actually just floating around in the solution. So if they're aqueous, they actually dissociate. So this just means you have potassium and iodine just floating around in a solution of water. And then the same thing for lead nitrate. Lead and nitrate are actually going to break apart. You have lead over here and you have nitrate over here. They're not actually stuck together. They're just floating around in the solution that they're dissolved in. In order for a reaction to actually happen, two of these pieces are actually going to have to come together and form a solid. So we'll take the first example. So potassium is going to bond with nitrate. So we're going to end up with KNO3. And again, charges are relevant here. So potassium has a +1 charge, nitrate has a -1 charge, and we can get that just by looking back at our chart. So K+, it has a +1 charge, and then NO3-, it has a -1 charge. So when those two come together, we just have KNO3. The reason you have this 2 out here is because lead, or PB, has a +2 charge. So when lead bonds with nitrate, the 2 goes outside of the nitrate. All right, so KNO3 is my first product, but we're going to create another product. We're always going to create 2 compounds in a double replacement reaction. So PB is now going to bond with I. So lead will bond with iodine. And when that happens, we have to look at the charges again. So PB is a +2 charge, and iodine, which is included under the halides, that's a -1. So when you have a +2 and a -1, that's going to give us a formula of PbI2. So the 2 from PB crosses over to I, the 1 crosses over to PB, and you just end up with PbI2. The next part, we have to figure out if this reaction actually happens. So if we take KNO3, we have to look back at the solubility chart, and we can either find K or NO3 on that chart. So we can see K is soluble, and there are no exceptions. Same thing with NO3, soluble, no exceptions. So that makes it pretty easy. We can just go back here and just write AQ. So that's going to be aqueous. So the K and the NO3 are still just going to be floating around in the solution, and they're not actually going to get together with anything. So now we have to do the same thing for PbI2. So we look back at the chart, we find I. So iodine is one of our halides. So that's right there. And the halides are always going to be soluble except when bonded to these 3 things. So normally anything bonded with I would be aqueous, as is the case when it's bonded with potassium. But PB is one of our exceptions. So it actually becomes insoluble. And if something is insoluble, that means it's a solid. So the way we indicate that, just in parentheses, just a parentheses S. So when lead bonds with iodine, they're going to create a solid. They're insoluble. So what that actually looks like in the solution is the lead is going to come together with iodine, and they're going to form a solid. So these two come together, they actually bond. The potassium and the nitrate are still just floating around in the solution. The solid that is formed in this case, we just call a precipitate. Now the last step, if I really want to be thorough here, is we have to balance my equation. So we have 2 nitrates on the left and only 1 on the right, so we can balance that by putting a 2 there. Now we have 2 potassiums and 2 iodines on the right and only 1 of each on the left, so we can finish it out by putting a 2 right there. And now we have our finished equation. Next example, we have sodium chloride and potassium nitrate bonding together, or reacting together, and we're just going to do the old switcheroo. Sodium is going to swap places with potassium. Potassium will now bond with chlorine, and now we go ahead and write our product. So sodium and nitrate are both 1 charges, so when those two come together, that'll just leave us with NaNO3, and then potassium is going to bond with chlorine. So again, potassium and chlorine are both 1 charges. You can just get that by looking over here. Potassium is a plus, chlorine is a -1. So these would be our 2 products. And now for the last step, we just have to figure out, is one of these going to be solid? And if so, then we know the reaction is happening. So we have NaNO3, so we can find sodium right there. Sodium is soluble always, so we know our first product right here is going to be aqueous. So if the reaction is going to happen, then our second product would have to be solid. So let's find potassium or chlorine on the other side. Potassium right there is soluble always, so our second product will also be aqueous. If this is the case, both of our reactants are aqueous, both of our products are aqueous, so nothing really changes. So the sodium, the nitrate, potassium, the chlorine, they're all just dissociated in the solution. So nothing is actually coming together to form a solid. So in this case, we would just say the reaction would not happen. This would be a perfectly acceptable way to write that answer, that there is no reaction going on here. We'll do one more example. So we have AgNO3 reacting with sodium chloride. So Ag and Na are going to swap places, and now Ag will bond with Cl. And both of those are 1 charges. So we have Ag plus and Cl minus 1. So AgCl is our first product. And then our second product, we're going to have sodium bonding with NO3. We've had sodium nitrate and NaNO3 in our previous 2 examples as well. So we already know that that is aqueous. And now looking back at AgCl, so we know Cl is in this category, usually soluble, but Ag is one of my exceptions, so it's going to be insoluble. So the way we mark that again is with the parentheses S. The AgCl would be the actual product that's formed, and looks like everything is already balanced, so this would be your answer for that problem. All right, so I hope that was helpful, and you guys can let me know if you have any questions.